The James Webb Space Telescope is an infrared observatory that observes the Sun at a distance of around 1 million miles from Earth. It searches for the first galaxies that emerged in the early cosmos and watches stars develop planetary systems. To know more about the workings of this advanced James Webb Space Telescope, just continue watching our video until the end. With a wider wavelength coverage and significantly increased sensitivity, the James Webb Space Telescope will expand upon and complement the discoveries of the Hubble Space Telescope. The James Webb Space Telescope, generally known as JWST or Webb, is the largest and most powerful scientific telescope ever built by NASA. It is a renowned observatory with a sizable infrared telescope with a primary mirror roughly 6.5 meters in length. From the first brilliant glow following the Big Bang to the birth of the solar system that can support life on planets like Earth to the progression of our solar system, Webb will explore every stage in the history of our universe. It will expand on what has already been learned by the Hubble Space Telescope. The most powerful space telescope ever created is the James Webb Space Telescope. Canada donated a research device and a navigational sensor to the enormous observatory, which will allow for groundbreaking astronomical discoveries. The Fine Guidance Sensor, Near-Infrared Imager, and Slitless Spectrograph, all the NIRISS research instruments, were donated to the Webb Telescope by the Canadian Space Agency, or CSA, or FGS. Canadian researchers will be among the first to take on the Webb Telescope's potent instruments thanks to the CSA's contribution, which guarantees them observation time on the telescope. Webb examines every stage of the history of the cosmos using infrared light, which is invisible to the human eye. 4 pieces of scientific equipment on the telescope can look through the cosmic dust to examine colder or more distant objects since they're made specifically to collect infrared light. At its earliest, the orbiting infrared observatory was launched from a location in French Guiana, which is on the northeastern coast of South America. It was built to be roughly 100 times more sensitive than its Hubble predecessor. An Ariane 5 rocket's payload bay has the telescope folded tightly inside. Along with providing launch services to the American National Aeronautics and Space Administration, or NASA, for Webb, the launch vehicle is a component of the European Space Agency's, or ESA's, commitment to the mission. When it reaches space, it disentangles from the launch vehicle and starts moving in the direction of the orbit point. One of the most difficult deployment sequences ever attempted will be carried out by the Webb when it's released from the rocket and begins to slowly unfold as it moves towards its goal beyond the moon. The Webb must first be powered by setting up the solar array. The Webb then deploys 2 unique pallets containing vital sun protection. The instrument package is raised onto a tower and placed where it will be used. The flap aids in stabilizing the telescope as the big sun shield is pushed against it by the solar pressure of the sun. The tennis court-sized sun protection is kept in customized coverings which are made available on the same day. The 5 layers are separated by deploying the sun shield's mid-booms and gradually tightening them. The secondary mirror's support structure is then put into place. The instrument deployment is finished 3 days later when the side panels of the primary mirror are extended. Looking back to when galaxies were first formed is one of the objectives of the telescope. Webb will accomplish this by keeping an eye on galaxies located more than 13 billion light-years from Earth. A telescope also glances backwards when it zooms out further. The light the telescope is observing takes time to reach the telescope from space. Since light has traveled for billions of years throughout the universe to reach us, we, therefore, view objects not as though they are today, but as they were when they released the light. A massive mirror is required by the telescope in order to gather light to observe dim and distant things. The amount of detail that a telescope can see depends on its mirror area size. The Webb telescope can see further into the past than Hubble because it has a larger mirror. Infrared and red light are deflected onto a smaller secondary mirror by Webb's primary mirror as it travels across space. The secondary mirror then directs light into the scientific instruments where it's recorded. The telescope must be protected from any bright, hot sources such as the sun because it will be looking for extremely faint infrared signals. The sun shield separating the telescope's hot and cold sides causes a significant temperature difference between them. Before we move on, please make sure to hit the subscribe button to subscribe to our channel for more interesting content just like this, and also hit the bell icon to get notified whenever a new video is posted. While Hubble may examine the universe in some infrared light, it will primarily study it at optical and ultraviolet wavelengths. Webb, however, will do the opposite. Astronomy relies heavily on infrared observations because newly created planets and stars are sometimes obscured by masses of dust that absorb visible light. These barriers can be crossed by using infrared light. The Webb telescope can observe this because infrared light will transit the dust particles rather than reflecting off of them. And that's one of our main objectives, said John Mather, senior project scientist for the Webb telescope at NASA's Goddard Space Flight Center in Greenbelt, Maryland. The telescope won't orbit the Earth as Hubble does. Instead, it will orbit the Sun at the second Lagrange point, often known as L2, which is around 1.5 million kilometers or 1 million miles from Earth. Joseph Louis Lagrange, an 18th century mathematician, is credited with discovering Lagrange points, which enable the gravitational attraction of two massive bodies, the Earth and Sun, to be equivalent to the force necessary for a small object, such as a satellite, to travel with them. Webb will take about 30 days to get to the L2 location, which marks the beginning of its orbit. Webb can follow the Earth as it orbits the Sun because of this equilibrium between the gravitational pulls of the Sun and the Earth. This enables the telescope to be continuously shielded from the Sun's light and heat, as well as that of the Earth, Moon, and satellites, thanks to its substantial sun cover. At the point of the L2 orbit, Webb won't remain still. It will instead move in a different, smaller orbit that is about equivalent in size to the Moon's orbit around Earth, which lasts for around 6 months. Unlike Hubble, which swings in and out of shadows every 90 minutes, Webb's smaller orbit ensures that it is out of both Earth's and Moon's shadows, allowing its instruments to operate continuously. The development and planning that went into Webb spanned more than 20 years. The Space Observatory is distinctive in many ways that help assure that it will accomplish its goals. Webb is the largest space-based telescope ever constructed, thanks to its 6.5-meter wide golden mirror. 18 individually adjustable hexagonal gold-plated beryllium parts make up the mirror. Webb possesses a tennis court-sized sun shield to shield itself from the sun's heat. Because the heat from the sun and Webb's own equipment would otherwise prevent the telescope from making accurate observations, one of Webb's instruments also features a refrigeration mechanism to keep it cool. Due to its size, Webb had to be folded up like an origami piece to fit inside the Ariane 5 rocket that carried it into orbit. Webb took around 2 weeks to fully develop before traveling for another 2 weeks to its destination. The Webb telescope also houses 3 partner-contributed scientific equipment: NIR-CAM from NASA, NIR-SPEC from European Space Agency, and MIRI from NASA/the ESA. These instruments join the Canadian-made NIR-ISS. Webb's transmitter signals are picked up by sizing radio antennas positioned all over the world and sent to the Webb Science and Operations Center at the Space Telescope Science Institution in Baltimore, USA. The Next Generation Space Telescope, or NGST, was renamed Webb in September of 2002 in honor of former NASA Administrator James Webb. Webb is a global partnership including the Canadian Space Agency, NASA, and the European Space Agency. And that is all for today's video. If you've liked the video, then please give us a big thumbs up. Make sure to subscribe to our channel and hit the bell icon to receive notifications. Also, express your valuable thoughts in the comment section below. We are going to explore some of the most mind-boggling stories, technologies, and cars from all over the world. We will explain the questions who, what, why, and how. Eager to unveil those? Stay tuned to Explained. Until then, goodbye. Also refer to other videos on our channel for more content, and we'll see you in the next video.